Alright, question 1 says, a body of mass 20 grams projected vertically upwards in a vacuum returns to the point of projection after 1.2 seconds. Now we have that gravity is given to us at that. Calculate the speed of the projection. So that's calculate the initial speed of the projection. Okay, so this body is just a 20 mass body and 20 gram mass body, right? Sorry, the mass is 20 grams and it's projected upwards. So in a vacuum there just means that, okay, there's no air resistance, right? So you can just, deal like there's no air resistance. And so it goes up and then comes back. So I'm drawing them separately, but this is just the upward and the downward, journey, right? And then so it came back to the starting point, point of projection. So it just went up and came back down in 1.2 seconds. Okay, so if it went up and came down in 1.2 seconds, now the idea is that in free fall, because this is free fall, right? The only force acting on the ball after projection is the force of gravity. So it's free fall, and in free fall, the upward motion and downward motion they're perfectly identical, right? So if it takes 1.2 seconds to go up and come down, that means that for just the upward part, it's going to take 0.6 seconds. All right, that's half the time. So to take half the time to go up and half the time to come down. So that this way we can just focus on this part of the journey and then calculate. So you focus on the upward trip. At maximum height, your velocity will be 0. All right, because for an object that is projected, what happens is that it decelerates until the maximum, until the velocity is exhausted, right? Then it now begins its descent. So a body would be reducing speed until it gets to the maximum height. There it stops. The entire initial velocity has been exhausted. Then it begins to come down with negative velocity. So your velocity at maximum height is 0 meters per second. Your velocity initially, which is u, is what we are looking for. And my acceleration is negative 10 meters per second. Okay, so we can solve for u. Why is your acceleration negative 10? Because its gravity is acting downwards. Okay, so let me list out all the variables and then we can just see which of our equations of motion can help us attend to this, right? So we have v is 0 meters per second, that's final velocity. U is well unknown. T is 0.6 seconds because we are dealing with just the time to go up. And my acceleration is negative 10 meters per second squared. Sorry. Okay, so solving for u, the equation that we can use that connects all of these variables is v is equal to u plus at. Of course, there are 4 of them, right? There is v is equal to u plus at, there is v is equal to u squared plus 2s. Sorry, v squared rather is equal to u squared plus 2s. There is s is equal to ut plus half at squared. And then there is s is equal to, open a bracket, v plus u over 2. Close the bracket, then all of that times time. Okay, so those are the 4 equations of motion, uniformly accelerated motion, and you must know them. If you do not know them, my recommendation is that you just pause and just go and learn them, right? But I expect that for you to have come this far, you know them. Okay, so the one that has all of these variables is v is equal to u plus 80. So we can just plug in. We'll have where do I right now? Okay, so we'll have 0 is equal to u plus minus 10 times 0.6. all right, so 0 is equal to u plus 6, sorry, u minus 6, sorry, plus times minus is minus, so u minus 6. all right, so 10 times 0.6 is 6. So solving, I can just add 6 to both sides. I will have u as 6 meters per second. So your initial velocity was 6 meters per second. That's C. Alright. Alright, so question 2 says, a body is thrown vertically upwards. Its velocity at the maximum height is 0. Alright, free fall. A body is thrown upwards, the velocity at the maximum height is 0. So what happens is that the velocity keeps on reducing. Alright, so you probably projected it with some initial velocity, but because gravity is acting downwards, negative. Alright, so it keeps on, pulling away from your velocity, reducing the speed until it gets to the maximum height where it stops, and then it begins to fall down with negative velocity. All right, so the correct option is, and you should know this, right? Whenever a body is at the maximum height, the velocity is 0. All right, a body that is thrown up, acted upon by only gravity. All right, so that's question 3. Question 4, a ball is projected horizontally from the top of a hill with a velocity of 20 meters per second. If it reaches the ground 4 seconds later, what is the height of the hill? All right, so there are 2 ways to solve this, right? You can solve it by, resolving both the left-hand side and the right-hand side of the, that's the left-hand side, sorry, the horizontal and vertical bits of the motion, so you calculate the vertical as free fall, and then you calculate the horizontal as, a system with 0 acceleration, because there's no acceleration horizontally, right? But we won't do that. We'll just use the formula. So there are 5 formulas you must learn for projectiles. There's one for maximum time of flight, range, and maximum height. But then for horizontal projection basically means that your object is projected this way, right? So there are 2 formulas. The first one is your time of flight is equal to square root of 2h over g, and of course your range is just your initial velocity times your time, right? So your range would be u times square root of 2h over g. So you must know these 2 formulas, all right? And then the other 3 for projectile motion. That's for full projectile, when it goes up and then comes down. This one is just projected horizontally, right? So it just does, the motion where it just falls down like this. So it's kind of like a half projectile. I call it a half projectile motion. Okay, so when we list out our variables, we'll know which formula we have to use. So my time of flight, time is equal to 4 seconds. My height is what I'm looking for. My initial velocity u is 20, and my acceleration is 10. All right. So 10 or negative 10, right? So if I'm using negative 10 here, then that means that my height would be negative, basically. All right. So whichever way. So we have all of these variables here. I think we can use the first formula, right? We don't need u for anything. We just need t, h, and g. All right. So that will be 4 is equal to square root of 2h over negative 10. All right. So I can square both sides. I would have 16 is equal to 2h over negative 10. All right. So 2h is equal to negative 160. So h would be negative 18. All right, negative 80 meters. So the reason why your height is negative is because I took acceleration due to gravity as negative, and that makes sense, because if your height is negative, it just describes the motion of the object, that the motion that the body was falling down. So the displacement, the change in height is negative, so it's negative 80. All right, so some teachers will say just use positive, and that's fine, but you just need to be careful, to know what you're applying, so that you don't get it mixed up. All right, yeah, but the answer is 80 meters. So the height is 80 meters. The reason why I got negative 80 is because of that negative, the fact that the ball is falling down. So that means that the displacement is negative. All right, so that's option C. So again, one last time, you could have used G as 10 and you would get H as positive 80, and that's fine. So remember, you must learn both these formulas as well as the other 3 for projectile motion. Again, there are 5, right? 5 formulas you must know. Okay, question 4 says, a ball is projected horizontally from the top of a building, top of the tower, neglecting air resistance. Which of the following statements about motion is or are correct? So it's projected off the top of a building. So let's see if we can do that. So we have a building here. So let this be the lead school, and then we just took a ball and we shot it out this way, projected it out horizontally, straight this way. All right, we shot the ball off straight that way. So neglecting air resistance, which of the following statements about the motion is true? So the vertical acceleration of the ball decreases as it falls. That's false. Your vertical acceleration is constant. It's always negative 10 meters per second squared. gravity doesn't change, right? Your vertical acceleration is gravity, so it doesn't change. It's negative 10 meters per second squared. All right. The vertical velocity of the ball remains constant. Yes, that's true, because the vertical force on the ball, which is gravity, yes, that's the weight of the ball, remains constant, because the mass is constant and gravity is constant, and weight is mass times gravity, right? So this is correct. This third one is that the vertical speed of the ball increases as it falls. That's true. All right, because so here's what happens when you project the ball this way. The ball is your acceleration horizontally is 0, so that means that your velocity horizontally will be constant. All right, but vertically it started out with a velocity of 0, right? So that's your uy is 0. But then because acceleration is acting downwards, it begins to pull it down. So that means that the ball begins to move at a higher velocity downwards. It starts with 0 velocity downwards. That means it wasn't even falling at all. But because gravity is pulling it down, it begins to, again, decrease the velocity. But let's talk about speed. Increase the speed. All right. So it begins to fall down faster and faster. So the correct option is option A, because the vertical speed of the ball will be increasing. The ball will be pulled downwards, so it begins to generate some vertical velocity and begins to come down faster and faster, right? Faster and faster. The vertical force of the ball is constant because weight is equal to mass times gravity, so it's constant, right? There's nothing changing the mass or changing the acceleration due to gravity. Then the vertical acceleration of the ball decreases as it falls. That's false, because your vertical acceleration is constant, is negative 10 meters per second squared. Nothing changes gravity. All right, so that's question 4. Let's take on question 5. Question 5 says, a body is projected horizontally from the top of a cliff 45 meters above the ground. The body lands at a distance 30 meters from the foot of the cliff. Calculate the speed of the projection, and we are giving g as 10 meters per second squared. Okay, so this is horizontal projection, right? I call it a half projectile, in that the object is just shot off like this. Okay, and so it's not like the full one that goes up and then comes down. So this one is just shot off the top of the building like that, and so it's just going to, your motion typically will just be something like this. Okay, so there are two ways to solve this, right? You can separate the motion on the vertical and the horizontal, and then solve them separately, right? Or you can just use formulas. So for the sake of the fact that we're preparing for an exam, I won't go into the separating into vertical components and horizontal components and stuff. I think it's beautiful when you understand it that way, but for the sake of your exam, it's just better to stick to your formulas. So there are two formulas you need to know for horizontally projected projectile motion. We have the formula for time of flight, which is given by t is equal to square root of 2h over g. And then we have the formula for the range of flight. Your range is u times square root of 2h over g. All right, so your range is just your initial velocity, your initial horizontal velocity times your time, basically. So we'll list out our variables and see which of these two formulas we should use. So we are given our height as what? 45 meters. And then we're told that the body lands at a distance. So my range is 30 meters. We are asked to calculate u. And we are told that our acceleration to gravity is 10 meters per second squared. Okay, so I could stick with my gravity as positive 10. If I do that, then that means my range will always also be positive. But if I decide to write my gravity as negative 10, considering the direction, then that means that my range would also have to be negative because the body is falling down. So either way, it cancels out, right? So if you're going to go negative 10 meters per second squared for your gravity, then your range should also be negative 30, all right? Or if you're going to go positive, you go positive also, just putting that out there. The formula that helps us is this one, yeah? So that's the one that has all the variables that we need. So we just substitute right in. We're going to have range, which is 30 meters, is equal to u times the square root of 2h, that will be 2 times 45, over acceleration due to gravity, which is 10. Okay, so the height is actually 45, right? So if we're doing if we're going to call your g -10, then your height would have had to be -45. So be very careful on that. Okay, so let me do it with this unit here. So we can solve backwards for u, right? We just keep on breaking it down one by one. So we'll have 30 is equal to u times 90 over 10, right? Square root of 90 over 10. So 30 will be equal to u times square root of 9. So 30 is equal to u times 3. I can divide both sides by 3 and I would get u as what? Sorry, u as 10. All right, so my u is equal to 10 meters per second. So my initial projection horizontally, the initial velocity given to it was 10 meters per second, purely horizontal velocity. So that's option A. Question 6 says a body is projected into space with an initial velocity v0 at an angle theta to the horizontal. Which of the following statements is or are correct about its motion? Okay, so this is speaking about a full, what I call it a full projectile now, right? The one that begins from the ground, all right? Begins from the ground, makes an upward journey, all right, hits a maximum height, and then begins to make a downward journey, right? So this is, the kind of projectile, and there are formulas you need to learn for your time of flight, maximum height, and range. And so this is just checking on whether or not you know your formulas, okay? So for time of flight, the formula for time of flight is 2u sine theta over g, right? So this is wrong. Time of flight is 2u sine theta over g. Maximum range is u squared sine squared theta over 2 equal to u squared sine squared theta over 2g. All right, so this is correct, and then your range is this formula for range is wrong, right? So the correct answer is option A. All right, only the second statement there is correct. All right, so you must learn your formulas. You must learn your formulas and know them. There are 5 of them, right? There are 5 of them that you need to learn. The 3 for there are 3 for full projectiles, as it were, like the one that's projected from the ground, that would make an upward, an upward motion and then a downward motion. Then there is another one for, there are another 2. We have another 2, or we have other two other we have 2 other formulas to learn for the horizontal projections. So you must learn all of them, right? You must learn all of them. So that's it for question 6. Alright, so question 7 says a body is projected vertically upwards with a speed of 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. Okay, so this is basically free fall, right? So this is free fall, and we are just looking at a vertical motion, right? The only twist to it is that the body starts from a platform. All right, start from a platform, say that is 2 meters above the ground. So let me put this here. So this height here is 2 meters. So the body would go up, of course, as with all free fall, to a maximum height. We can call this the part A of the journey. Okay, part A of the journey, and then it will fall down to the floor. Okay, to fall down to the floor, and we can call that part B. We can call this part B. good. So part A and part B. So the idea is that the time of flight for part A plus the time of flight for part B would give me the total time of flight. Okay, so let's look at part A. Let's start with part A. I really just try to squeeze out all of the variables that we know or that we have. So it was projected from this point here with an initial velocity of 10 meters per second from a point 2 meters above the ground. So the 2 meters above the ground doesn't really affect part A. It's part B, because it's then that, okay, the distance for part B will be 2 meters plus whatever the distance for part A is. But you know, for part B, for part A, the 2 meters doesn't really matter. We're looking for time. Now, because it's free fall, we know that the final velocity for part A would be 0 meters per second, right? So it's going to slow down until it comes to a rest, right? And then the acceleration for part A is negative 10 meters per second squared. Okay, so that's the acceleration for part A, negative 10 meters per second squared. So to get our time, we can use v is equal to u plus 80, the first of the equations of motion. So we'd have this, we are just doing it part A now, just to get the time to from here until when it gets to the maximum height. So we'd have v0 is equal to u 10 plus minus 10 times t. All right, so this will be minus 10 is equal to minus 10t. I divide both sides by negative 10. I get t as 1 second. Okay, so the time of flight for part A is 1 second. So we have the first bit here. T is equal to 1 second. Right, so if I can get the time of flight for part B, then I'll be good. Right, I just add up the time of flight for part B, the time of flight for part A, and I'll have my answer. So for part B, what are all the variables that we have? So part B is the return journey, right? The return journey. So our initial velocity for part B will be the final velocity for part A, because it's when it's completed part A that it started part B. So my initial velocity for part B would be 0 meters per second. We are looking for time. Our acceleration is negative 10 meters per second squared. What else? We don't have final velocity. We don't have distance. Okay, but we can get distance, right? We can get our distance. And how do you do that? We can find the distance for part A and then add 2 meters to it, because the distance for part B would be however far part A traveled upwards plus 2 meters. Okay, so we'll come back to our part A variables and then see how we can find out our distance. So we can use any of the equations of motion at this point, really, because now we know what time is. Now we know that our time is 1 second. Right, we know our time is 1 second. So we can use let's use let's use s is equal to v squared. V squared rather is equal to u squared plus 2as. So v squared is equal to u squared plus 2as. All right, so let's use that. So this to solve for s, right? So that will be 0 squared is equal to 10 squared plus 2 times minus 10 times s. All right, so this will be 0 is equal to 100 minus 20s. All right, so that means 20s is equal to 100. If I divide both sides by 20, we get s, which is our displacement, s as 5. So s is 5 meters. All right, so that means that this distance here for part A that it went up is 5 meters. So that means that the distance that part B fell through is 7 meters, right? So that's 7 meters because we have 5 plus 2. Okay, so now we have all the variables we need to, employ our equations of motion. I think the equation of motion that works for this set of variables here should be S is equal to ut plus half at squared. So S is equal to ut plus half at squared. S is 7, so we can just plug in, right? S is 7 is equal to u is 0, so 0 times t plus half times minus 10 times t squared. Yeah, so just put in t squared. All right, so because if I'm taking my acceleration as -10 as I am, that means that my displacement would have to be -7. All right, my displacement will have to be -7 because the object is falling down. So just to point that out. So this will be -7 is equal to, this guy cancels out. This will be -5t squared, right? Because 2 times -10 is -5. So I can divide both sides by -5, and I would have 1.4 is equal to t squared. If I take square root, take square root of both sides, t would be equal to 1.18 seconds. So my time here is 1.18 seconds. Alright, so going back to the question asking me for the total time of flight will be 1 second plus 1.18 seconds. So t will be 1 plus 1.18, well, total time, let me use capital T, which will be 2.18 seconds. Alright, so that was easy enough, right? I really just split up both parts of the motion into two and then solved for each part separately. You might want to, if you didn't get this, then it makes sense to try to resolve it yourself to just ensure that you understand how we navigated the problem. Alright, that's for question 7. Let's move on to question 8. Question 8 says, a body is projected with an initial velocity u at an angle theta to the horizontal. The time taken by it to reach maximum height is given by the expression. So that will be u sine theta over g, right? So that's option D. Why? Because your total time of flight, of course, is the time it takes you to go here and then come back, right? So the time to the maximum height would be half of that formula. So your total time of flight t is 2u sine theta over g. Alright, 2u sine theta over g. So the time just to get to this point here would simply be u sine theta over g. Alright, so it's half of that. That's option D. Alright, that's question 8. Question 9 says, a body is projected with an initial velocity u at an angle theta to the horizontal. If your arrow marks the maximum range, what does the relation u squared over arrow marks represent? U at an angle theta to the horizontal. So a body is projected this way. Alright, so let's work with our formulas. Our formula for R is u squared sine 2 theta over g, right? That's R. Now your range will be maximum when theta is 45 degrees, alright? So because that will make 2 theta to be 90, and then sine 2 theta becomes 1. So 1 is the maximum range that you can, 1 is the maximum value you can get for sine anything, right? So anyway, we know that R would be, when is R max, right? It's going to be U squared. So sine 2 theta becomes 1. Again, because theta is 45. So sine 2 theta would be equal to sine 90, which would give you 1. And 1 is the maximum value that you can have for sine. Alright, so that's proven mathematically. You can also use the simulation on phet.com on projectiles and vary your angle, right? And then see that, of course, anything below 45 or above 45 gives you less of a range than what you have at 45 degrees. Okay, anyway, so I hope I've established that. So that means that R max really would be U squared over G, because sine 2 theta will be 1, right? So that means that if we are asked to find what U squared over R max is, well, that you can make G subject of the formula, and then this pops right out. You have U squared over R max. So the answer is G. G is U squared over R max, which is acceleration due to gravity. That's option C. Okay. Number 10 says, a coin is pushed from the edge of a laboratory bench with a horizontal velocity of 15 meters per second. If the height of the bench from the floor is 1.5 meters, calculate the distance from the foot of the bench to the point of impact on the floor. So they are basically asking us to calculate the range. Alright, so let's have this as a table. So this is our table, right? It's our nice table legs here. Okay, so we have this coin, and then this coin is projected off with an initial velocity of 15 meters per second. So this velocity is purely horizontal, right? We are told that the height here is 1.5 meters. Calculate the distance from the foot of the bench to the floor. So you can solve this really by just doing by resolving your free fall vertical bit separate from your horizontal bit, and just, it's really beautiful, but for sake of work and the fact that you're writing an exam, my primary recommendation is that you should just use your formulas. There are 2 formulas you need to learn for horizontal projection, and 3 you need to learn for the full-on projectile, where it makes an upward motion and a downward return journey. But so you need to learn 3 of them. So, but for your range, the 2 formulas you need to learn, there is T is equal to square root of 2h over g, and then there is range, will just be your initial velocity times this, u times square root of 2h over g. Alright, so let's substitute. Range R, which is what we're looking for, so R is unknown, is equal to u 15, right? We wrote that here, times square root of 2h, that's 2 times 1.5, right? Your height is 1.5 over g is 10. Sorry, g is 10. So if you decide to take g as minus 10, then you must also take your s as negative 10 and negative 1.5. Why? Because the object is falling down, right? You must take your height as negative 1.5 and to still cancel out. So just be wary of that. Okay, so proceeding, we have our range would be 15 times square root of 3 over 10. Alright, so we can use our calculator for that. 1 second, because that's just going to be 15 times square root of 0.3. 15 times square root of 0.3. So the answer is 8.22, right? 8.22 meters. Okay. So please make sure you learn your formulas. Alright, that's for question 10. Okay, so 11 now. We're up to 11. Sorry, 1 second. Sorry. Okay, so the answer to this was A. The answer to this was B, I believe. Okay. So question 11 says, a football is kicked at an angle of 45 degrees to the horizontal over a defense lineup with a velocity of 15 meters per second. Calculate the magnitude of the horizontal velocity at its highest point. Okay, good. So if you understand your what's it called, projectile motion from the first principles, you realize that there are two parts to the motion. All right, there's what goes on the vertical and there's what goes on the horizontal. All right, and then both of them are independent of each other, so you can attend to them separately. For vertical, your initial velocity is u sine theta, so uy will be u sine theta. It's basically free fall. Your acceleration is negative 10 meters per second squared. At maximum height, your velocity, your final velocity is 0. All right, so at maximum height though is for maximum height. So just the works for your vertical, your free fall, right? Maximum height velocity is 0, then it begins the return journey back to the ground. For your horizontal, your initial velocity would be u cos theta. So this is just the component, all right? The x component of your velocity. Your acceleration is 0 because gravity doesn't act, horizontally, acts vertically, and we are assuming no air resistance for just general projectile problems. So the implication is that if your acceleration is 0, that means that this guy is maintained, right? Your initial velocity doesn't change. So horizontally, whatever velocity you start out with is what you finish with. It's what you have at the maximum height, is what you have, anywhere along the journey. So basically, if they're asking you for the magnitude of the horizontal velocity of the ball at the highest point, it's still the initial horizontal velocity, right? So your ux would just be u cos theta, which would be 15 cos 45. All right, so 15 cos 45, I think that should give you 10.6. Let me confirm. All right, so 10.6. All right, so that's 10.6 meters per second. So that's option D. Option C rather. Option C. That's for question 11. Okay, so let's take on question 12. Alright, question 14. An object is projected with a velocity of 100 meters per second from the ground at an angle theta to the vertical. If the projectile's total flight time is 10 seconds, calculate theta. Alright, so we are told that an object is projected and the angle of projection is what we're asked to find, right? So we should look for theta, is unknown. We're giving time of flight as 10 seconds. We're giving the initial velocity as 100 meters per second, and we know gravity is 10 meters per second squared. Alright, we are asked to find the value for theta. So the time of flight is 2u sine theta over g. So it's a formula that you have to learn, right? There are three of them: time of flight, range, and maximum height, right? And then for horizontally projected, not this type that goes up and down, but just the ones that are horizontally projected, there are two formulas. There's formula for range and the formula for time of flight. So you need to learn all 5 formulas for your projectiles. Alright, so t is equal to 2u sine theta over g. We can plug in and solve backwards for theta, right? So we have 10 is equal to 2 times 100 times sine theta over 10. Alright, so I just plug in. So if I cross multiply, I would have 100 is equal to 200 sine theta. Divide both sides by 200, I will have 0.5 here, because 100 divided by 200 is half, is equal to sine theta. Okay, so from here we can say that theta would be the sine inverse of 0.5, So that means theta is going to be 30 degrees. Okay, good. So the question is saying, so theta is 30 degrees. But the question is saying, we are being asked for the angle with the vertical. Alright, so this theta that we use in all of our formulas is the angle with the horizontal. But what we are really being asked for is we are asked for the angle with the vertical. So they both make up 90 degrees, right? They are both complementary. So that means that this other angle here, because we have x plus 30, must give you 90 degrees, right? So that means that x is 60 degrees. So the angle with the vertical is 60 because we solved to get the angle with the horizontal as 30 degrees. So the correct answer is C. Alright, the correct answer is option C. Okay, question 15 says, an object R leaves the platform XY with a horizontal velocity of 7 meters per second and lands at Q. Okay, if it takes the object 0.3 seconds to fall freely from Y to P, calculate the distance PQ. Okay, so the first thing you need to know is that, remember we said that the horizontal and vertical bits of a projectile motion are independent, but what links them together is time. The time it takes to fall is the same time it's going to take to move, in the horizontal direction. So basically, this time of flight for the time it would have taken to fall is the same as the exact time of flight it used to cover the distance, right? So we have our time of flight for the projectile as 0.3 seconds. We have our initial velocity u as 7 meters per second. We have gravity assumed 10, even though it's not given to us, so that's 10 or 9.8, but we can go with 10 meters per second squared, and we are asked for range. So what is the range? So the formula for range is, your range is u times square root of 2h over g, right? But then this 2h over g here is the time, alright, is the time of flight. So your range is just basically u times t, which would be 7 times 0.3, alright, which is going to be 2.1 meters. Okay, so all of this is actually still your time. Your formula for time of flight is square root of 2h over g. Alright, that's for horizontal projection. Another way to think about it is this, alright, so we can even really just, not even focus on this formula and just say that because we know that the horizontal bit of the motion, the acceleration is 0. Alright, so that means that basically it's going to maintain a constant speed. So your range will just be that constant speed times how long it was moving at that constant speed, which is u times t. Alright, so yeah, the answer is 2.1 meters. Okay, that's for question 15. Question 16 says, at a birthday party, the celebrant cocked fruit wine. If the cork shoots out of the bottle at an angle of 40 degrees to the horizontal and travels a horizontal distance of 4.5 meters in 1.25 seconds, calculate the initial speed of the cork. So we know that your horizontal speed or velocity is going to be constant because there's no horizontal acceleration, right? So we can say that our range, horizontal range, will just be u times t, right? Where u is ux. All right, that's your horizontal. Velocity, right? Initial horizontal velocity. So we have 4.5, all right, because your range is giving us 4.5 and your time is giving us 1.25, right? So 4.5 is equal to ux, which is what we're trying to find, times time 1.25. So ux would be 4.5 divided by 1.25, all right? So we can do 1.5 divided by 4.5 divided by 1.25. It wouldn't have been that. Let me just 4.5 divided by 1.25. Oh, 3.6. Oh yeah, I was thinking 36. So ux is 3.6 meters per second. All right. But we are being asked for the initial, just u. All right. And we know that ux is equal to u cos theta, where theta is the angle with the horizontal. So ux is 3.6. So we're going to say 3.6 is equal to the value we are looking for times cos 40. So your initial velocity will be 3.6 over cos 40. All right, so that'll be 3.6 divided by cos 40. So I'm getting about 4.7. All right, so u is equal to 4.7 meters per second. Okay, so I mean it's pretty straightforward, right? I used the distance over time formula to find the horizontal speed, and I'm able to do that because I recognize that the acceleration for the horizontal section of the projectile is 0, right? So that means it's not speeding up, so that means the speed is constant. So it's just your regular distance over time formula that I used to find, but that's just for my horizontal speed. Now the speed they're asking you to find is the total speed, the combination of both the horizontal and the vertical, the resultant in that sense of both of them. That's what's usually given as the original speed. So let me make an illustration here. So we have this, and then your object is shot this way. At some angle. So this guy here, this guy here has some vertical component, the horizontal component here ux, and some vertical component here uy. So for the x component, that's what I use here because of course acceleration in that direction is 0, so it's easy to calculate to say that, oh, my velocity, which is constant, will be 3.6 meters per second, just distance times time formula. Then for my vertical now, it's I don't need my vertical, but for my resultant, I know that u cos theta is ux. Right, so if u cos theta is ux, then I could solve backwards, given that I know what theta is, to get the value for u. All right, so that's for question 16. Let's take on 17. All right, 17 says, at what angle must the nozzle of a machine gun be kept when firing to obtain a maximum horizontal range for the bullet? All right, so your formula for horizontal range is given by u squared sine 2 theta over g. All right, so g is constant and u squared, of course, your velocity is constant, right? We're not changing anything about the gun, we're just trying to vary the angle. So the question we really need to ask is, what value for theta makes this sine 2 theta maximum? All right, so the maximum value for sine anything is 1, right? As long as you're working with is 1. So if sine 2 theta is going to be equal to 1, that means that 2 theta would be sine inverse of 1, right? Does that make sense? So I hope it does. Sine 2 theta is 1, so 2 theta will be sine inverse of 1. So that means that 2 theta would be what? 90. So if I divide both sides by 2, theta is going to be what? 45. So it's when theta is 45 that when I plug it in here, I get the maximum value that can come out from all of this, which is 1, because sine 90 would be 1. Okay, so the correct answer is option B. And I think it pops up quite a lot, so it's something that you should just know, that the maximum, the value for theta that gives the maximum range is 45 degrees. Okay, so question 18 says, the angle at which a projectile must be fired to cover the maximum range is 45 degrees, okay? 45 degrees. So what happens is we can use, the formula for range formula for range is u squared sine 2 theta over g. All right, so keeping u and g constant, we are trying to look at, okay, what would we put here that will give us the maximum value for sine 2 theta, right? So sine of anything, the maximum value you can get for sine of anything is 1. All right, so this is the maximum scenario. So what value for theta gives me this maximum scenario? Well, if I have this as an equation, then you would agree with me that 2 theta would be sine inverse of 1, right? So that means that 2 theta would be 90 degrees. Divide both sides by 2, your theta becomes 45. So you have your maximum range when theta is 45 degrees. Okay, that's for question 18. 19. The diagram below represents the trajectory of a projectile with an initial velocity u. If g is the acceleration of free fall, the time taken to reach a maximum height is... Okay, so the time taken for the entire projectile motion, which is the formula you should have memorized, is 2u sine theta over g, right? That's the formula for time of flight. So time to go up to the maximum height and then come all the way down. But unlike this drawing, let me draw it properly. Your projectile motion is perfectly symmetrical about the maximum height bit, right? So again, it means that time it takes to get here will be the same as time it takes for this part will be the same as time it takes for this part. So that means that your time to get to the maximum height will just be half, all right? Half of the time it takes to do the entire thing. So if I divide this by 2, I would say t is equal to big T, total time over 2, which would be 2u sine theta over g. Well, I could just multiply this by half, right? Same as dividing by 2. I'll be left with u sine theta over g. All right, so the correct option is option D. Correct option is option D, u sine theta over g. All right, question 20 says, the diagram below represents the trajectory of a projectile with an initial velocity u. Calculate the time taken to reach the maximum height. Calculate the time taken to reach the maximum height. Take g as acceleration due to gravity. Okay, so the time for the entire projectile, right, from start to finish is 2u sine theta over g, right? That's the formula. The formula to go all the way up and then come all the way down, right? But to get to the maximum height, it's really just half the distance, and your projectile motion is perfectly symmetrical around the middle, right? Around the maximum height point. That's the middle of the motion. So that means that the time for this bit will be the same as the time for this bit, right? So, or the time for just the half, time it takes to just cover the half to get to the maximum height will just be this over 2. So small t, time it takes to get to maximum height, will be total time over 2. So we can say small t will be equal to 2u sine theta over g. Well, over 2, I can make that times half, right? So 2 cancels out to end up with t as u sine theta, theta over g. Okay, so my 2 sine theta, u sine theta over g. That's option B. Alright, that's question 20. Question 21. Alright, question 21 says, the ratio of the maximum range to the maximum height of a projectile is 4. Determine the angle of projection. So that's if I do range over height, I get 4. So what's the angle of projection? So let's try that. So there are 2 ways to do it, right? You can come up with the values for u and g, alright? Just random values for u and g, and then plug into both of, and then plug in each of these values for theta, right, into the range and the height formula, and then see which of them makes, gives you a ratio of 4. All right, that's the first way to do it. But the other way to do it is just to find the ratio of the 2 formulas, right? So maximum range is given by, I believe, u squared sine 2 theta over g, and then my maximum height is u squared sine squared theta over 2g. And you're being told that this ratio is 4. Alright, so ratio is really just division, so that means that this divided by this is equal to 4. Alright, so let's start with this side. I can, flip this fraction, right? So flip this, and I would have flip the maximum height. So I would have u squared sine 2 theta over g times, then we'll find the reciprocal. That's the word I was looking for. Find the reciprocal here. So just regular fraction operations, right? Okay, we can proceed. So now we can cancel out g. We can cancel out u squared, and I can say 2 sine 2 theta. So let me continue up. So I can say 2 sine 2 theta over sine squared theta is equal to 4. Alright, so here again is another place I can just plug in all these values and test. Just plug in 45, 60, 0, and 30 and try out. But if you still want to work with trig, then I think sine 2 theta should be 2 sine theta cos theta. I think so, right? Yes, it is. So that means that this would be 4 cos, okay, no, let me plug in properly. So this would be 2 so 2 sine theta cos theta, then times the 2 outside. Okay, so this is sine 2 theta is 2 sine theta cos theta, so 2 times that, all right, over sine squared theta, which is just, let me write it as sine theta times sine theta is equal to 4. Okay, so just track with me. We are doing math now, no longer physics as here. So this can cancel out this, and we would have 4 cos theta over sine theta is equal to 4. Okay, good. So that means that cos theta over sine theta is equal to 1, right? Okay, good. Now I can cross multiply this and say cos theta is equal to sine theta. All right. So just cross multiplying this, right? But then I can also say, or I can say, if I divide both sides by cos theta, I can say sine theta over cos theta is equal to 1. But sine theta over cos theta is tan theta, right? So we'll say tan theta is equal to 1. So if I do tan inverse, so theta will be tan inverse of 1. So theta will be what? 45 degrees. Okay. So I need to help you now. So we started from here. So this was part 1. Sorry, I'm just trying to arrange what I did. And then we ended up here. Yeah, so this is part 2. Sorry. This is what we plugged in, right? And part 3. Part 3. And then part 4. So sorry, because I know I wrote all over the place, right? So I'm just trying to help you track. So you can try it out yourself. It's again, you could really just have use any value for U and G plugged in, and it might be faster for some people, and for some people too. If you're not taking further maths, I doubt that you'll be exposed to these trig identities. And I don't know any easier way that one can solve this actually. So maybe plugging in would be an easier approach. Just plug in the value for U. Say okay, maybe use 10 G's, or use 10 G's 10, right? And just now plug in 45, 60, 0, and 30 into each of the equations and find their ratio and see which one gives you 4. But if you want to go this route, this is also fine, and you can learn the method itself. This bit here is the main part that I feel like might have stumped some people. If you did not know your trig identities, your trig identity for sine 2 theta. All right, that's fine. You can also let me know in the comments if there's an easier way, maybe. That's the method I do know. All right, 22 says the time of flight for a projectile motion is given by the expression your time of flight t, so it's one of the formulas you have to memorize, is 2u sine theta over g. Very important that you do not forget your formula. All right, 2u sine theta over g, that's option A. You don't want to be looking for it when you need it or be trying to prove it when you need it. All right, you want to know it. Okay, so that's the end of this bit. Thank you, and see you in the next video.